started on our journey. So first thing we're going to start is on methodology. When we say methodology, that means designing is very important. When we say designing, it means that it's not just RESTful design. It's making sure whether that is the right approach the industry is taking. That's very important. Sometimes people try to build order objects and they're not building it well. For example, you're building a microservice. Let's say you are building a microservice here. This microservice which you're building now is interacting with the private cloud and it's also interacting with the public cloud. Now, no matter how good microservice you're going to create, you're going to have a private cloud to deal with. You're going to have a public cloud to deal with. Yeah, that means you're going to have security issues. Yeah, you're going to have security issues. You want to make sure you protect yourself from those security issues. So, what kind of issues you're going to get? You're going to get an insecure access. Critical things can be exposed to the trust boundary. You're going to have a problem with performance. Performance issues can come in. Throttling issues can be there. How to resolve those issues. And then you don't want to build in silos. Now, perspective here, there are two kinds of perspectives are there, guys. One is responsive design. Which one is better? Responsive design is better or mobile first design is better? What do you guys think? Huh? Responsive design is better. Somebody saying responsive design is better. Anyone else? So if you think about it, mobile first and responsive are almost the same. To your point, the perspective is that you are testing it in mobile first, and then you're elongating, making sure that it's done. So these are two different kind of approaches are there. Where we are looking at APIs as a way to connect. That means that your API is the gateway for everything you're doing. You're developing in the system. Your microservice you're building, it's the cornerstone. That means your API is the first user interface of your application, the microservice you are trying to create. Your API comes first, then the implementation comes. Now that's where the API gateway pattern is there. Like no matter who is calling the system, that the API gateway comes in and it calls. Now one other thing which comes in is that people look at this and say that, oh, what happens to the API gateway? Now everything is going through API gateway. What is the single point of failure here? Huh? API gateway. That's what you're going to say, yes? Yeah? But that's not true. That's not true. It depends on how we design our solution. So what that means, when I say designing is very important, guys. When I say design, that means that the same endpoint, you can provide a different endpoint to a VIP customer. You can provide a different endpoint for internal customers which you have got. So that's the key thing which you have to understand when you're building your design. Now let's take a look at our first assignment. So I'm going to go through assignment, guys, because like we all like to do the assignment. We all like to look at the assignment and work with those assignments. So think about the first assignment which we got here. The first assignment is Amazon.com. How many here use Amazon.com? Yeah, you're familiar with it. It's pretty nice design, and and then what I'm going to do is I'm just going to go in Amazon.com and open this link. So this is what is being asked for us to do. I'm going to make it a little bigger for us to look at it. Now this assignment is given to us. As an Amazon.com, you are being designed as an architect. You have to go across the globe and design what are the key features of Amazon.com. You want to find out how we manage the supply chain and logistics solution. This is the assignment given to us. We have been given an assignment that we need to know the logistics, we need to know the inventory control, third-party systems, and then we need to make sure that we analyze and create a security for our system. That means we need to come up with what products API, yes? We need to come up with orders microservice, shipping microservice, advertising microservice, yeah? So that's what we need to come up in our solution. So let's take a look at how we're going to do it. Okay, so in order to do that, let's talk about this for a second. So what's happening is the user is logging into the system. When the user logs into the system, first thing what it does, it creates an online store, and then in the online store I create a cart. Within the cart, now I'm having some coupons, and after the coupon is been sent, I send that request out from here to inventory. Now inventory looks at that request, process to the supplier, using the logistic department, they send it to us, and we need to have a better customer satisfaction at the end. Yeah, is that our goal for today? Yeah. So So what are the challenges which we are going to get? We are going to get these challenges from the complexity perspective, wide range of products. It's not like one product. There are 20, 30 products are there. Not 20, 30 products are there. Millions of not only products, but millions of vendors. How do we design for the millions of vendors? Scalability, security, consistency. So, and then integration, versioning. How do we version the APIs? Now, if you are coming here, I suggest you come tomorrow's session, which is in the main hall for the API design, because these two will really help you get like the full content of what I'm trying to describe to you, and the documentation. The perspective is this. Perspective is that you want to focus on the exposing of the APIs. Once you expose these APIs, the business APIs can come on front of it. So who's going to create the business APIs? Business users can create the business APIs. And then based on that, another user can create an experience API on top of it. So experience APIs are built, microservices are built on top of this API. Make sense? So that's the main thing we'll be focusing on. Next is eBay. eBay follows a similar model. You have certain products, and then the vendors can sell those products and be able to deliver the solution. Now eBay has certain other things, like you can sometimes you can do bidding also, but that's the main other feature which it has got. How do we follow all these best practices, expose the internal services, and that's useful for the app developers, and still be able to create and maintain the API? Now we all know, like we are all building a big system. That big system is using REST API, SOAP API. There is a lot of APIs are there lingering around. So first thing is, this is the anti-pattern, by the way. Sometimes we have this as part of our system. We have to deal with the monolithic app where we have this solution. A big system is there which is exposing some XML or an API. What we need to do is look at, in today's discussion, what are the steps to fix that. Now we can create a standard committee. Like how many here are go to architecture like boards, and you create a committee and then you're working on that. Yeah, we all go and try to influence. Hey, how we do this solution, or we sometimes create a copycat. What I really like is a Zen philosophy: monkey see, monkey do. Okay, what that means? Amazon has already faced this problem, guys. You look at how they are doing it, you just copy that, na? So instead of creating your own thing from the scratch, you do this approach, which is monkey see, monkey do, which will always be successful. So the first thing which you need to do is to create an API facade layer, and I will talk about the ideal design in next 10 minutes. Hopefully, we'll be covering the ideal design, what that looks like. Once you have a good understanding of it, then you'll be able to build it. That means you create the ideal payload for yourself, and then you implement the data stuff, and then call the old system or the new system. The perspective is you mediate, call the old system. I'm perfectly fine doing that, but create the design. Create what? Ideal design. So that's the main thing which I wanted to bring in here. So think about this e-commerce solution you're trying to build. The Amazon is not just calling Amazon. Amazon is calling customer management solution, CRM, which is then calling ERP solution, which is then calling logistics solution. So this is not just like one API which is being called. It's calling multiple of these solutions is being called. So that's what we need to figure out. How do we create this kind of structure? Okay. So what that means, that now I have got this assignment for us to look at, where I'm calling multiple systems. So you think about this multiple system problem. You have been given a problem where you have order service, which you need to create list for those particular order service. You want to make sure you create a facade. You have a deliverable, what you need to give in open specification. So everything needs to be in open specification, yeah. So that now you are able to use that as a solution. So you create the facade. So now after creating the facade, first thing is get the requirements. Yes. Find out what are the abilities for my API, what my microservice needs to provide, including retrieving the old history of the data. Based on that, now you create the get, post, and put methods. Yeah. Now what we are doing is we are creating the architecture for security and other things on top of it. So now we are building our solution on top of this. So that's where the great responsibility comes, guys. That's what we are talking about. So what's this methodology I'm talking about? One of the book which also talked about some portion of that methodology, not all of it. I added 3-4 things on top of it. Is Leonard Richardson RESTful Web's API. So something a good book reference for you. So first thing first is keep journey kiss, which is keep it simple, stupid. Keep it short and simple. Why that is important? Because we are trying to create source to destination. That means our RESTful APIs or microservices which we are trying to create, don't try to do 100 things with them. Okay, it solves one purpose and only that purpose it solves. Okay, that's the key thing. And if you Yagni is another principle which comes in, you are not going to need it. Okay, you don't need that big thing. You are not able to do the whole project because of that big thing. So that's something you don't want to do. Sometimes this comes, the product owner is saying, can you pass me a salt? I said that I know I'm developing a system to pass arbitrary contentment. Say it has been 20 minutes. It's going to take like 1-2 weeks to do it. You don't need it. If you don't need it, don't try to make it complicated. So there are few views to look at. What is inside out approach? From inside, from my system, which systems I need to call, right? So that's number one, which is there. Number two is outside in approach. That means from outside, which systems are calling me. Once I know these two things, once I know who's calling me and who I am making a call to, those are the contracts which we need to create. And what kind of contract do we need to create? Industry standards. Don't try to build your own model for an order which is not needed. So Yagni, you're removing things, you're making it easier for people to use the system and making it simple. And I will not repeat myself. That's something which is also there. Don't try to repeat yourself again and again doing the same thing which we are talking here. So Gardner talks about it now. This is an assignment which is also there here. Gardner talks about this also. It says that persona-based journey. Persona-based journey, customer-driven contracts. So let's take a look at this. So I gave assignment because that kind of makes it easier for us to look at. So what this is saying is that identify the customer personas. Identifying the personas are very important. What kind of personas? Internal and external, both personas, which is using the system. And then once we do that, then define the API capabilities and put it in the specification, then using it. Now, when we are saying focus on the API customer, design for usability. Now, that means how they are going to use it in the UI. Base the API, base the API using that, and build the API strategy based on that particular model. You can read through it, like there are some metrics you need to consider. One is the response time. What should be my response time? That needs to be, you have to say, like, hey, is it 1% network delay? What's the response time? 100 milliseconds, 250 milliseconds, 250 milliseconds from last 11 years is the same number. It is coming. Microsecond is new millisecond. Repeat with me. Microsecond is new millisecond. That means we are not talking in millisecond, but we are talking in microsecond in this case. That's something which is important. You build the contract and then you work on that particular contract driven development. And now another thing you can put is agile design approach, where you're trying to say, hey, let me build this API and then build on top of that particular API. Simulation approach is another one where you simulate the whole scenario or 2 or 3 scenarios before you start implementing the API. And sometimes this will give you better results than actually building the same solution. Now let's take a look at the e-commerce system which we just talked about. I'm calling it Zomazon. We're building Zomazon right now. In this e-commerce API, first thing we need to do is list the semantic descriptors. Now, semantic descriptors, what are the semantic descriptors for Amazon? Tell me. Come on, quick. You're going to sell the products. Products, yeah. You're going to have products, you're going to have orders, you're going to have customers, you're going to have, reviews. You're going to have sales employee who's going to sell that particular product. You're going to have a card. Hey, this is the dollar amount. Hey, you want to pay the money, yeah? The person has to pay the dollar, yeah, some money to us. Yeah, shipper, somebody will be there and supplier will be there. So this is an assignment which will give you an understanding of what are the semantic descriptors you can have. How many products? 100 million products, you will have a different solution for it. Yeah, 1,000 products, you have a different solution for it. Now start conducting the research of these semantic descriptors on use in other APIs. Now you're trying to model somebody, copycat. I love the copycat. By the way, there's sometimes that works better for us in our design. Now with that, you come up with products with all these attributes, and I'll tell you exactly how to do that in a second. So this is all the attributes which are there, but then there is something called um, uh, as draw state diagram. Now you want to draw state diagram. If you see here, order has order details. That means an order can have multiple products in it. An order detail can have a products associated with it. An employee is selling the product, and a customer is there who is going to buy that particular product. A customer can buy a lot of previous products. Yes. Now, based on that, domain-driven design wise, like Eric Evan talks about this also. He's saying that hey, you are creating an order. Customer and product are these are the main entities which are there. When you create an order, you are creating an order association with line item for different products. Yeah. What is the payment method for it? And you're also adding monitoring values like weight. How much is the weight, size of the product, color of the product? So that depends upon that. Your price might also change. Yeah. Now you are coming up with the diagram, which we all know this. So I'm not going to spend time here. So order has order line items. Now, based on that, now if you think about this bounded context in this particular case, now sales, what's really happening is I'm generating a campaign. That campaign is now generating leads for me. Leads are now generating, order. They are filling in the order. Order entry is being done in the customer solution. Then inventory is being sent from us. Now billing is done, accounting is done, and then if something goes wrong, we are able to fix that. Now there is always an analytics. There is always an analytics which is running all these things and seeing, hey, how can I improve this solution? That said, you're trying to create bounded context. So the next thing we need to look at is bounded context. That means say that sales context, sales can have a territory. Like for example, in India, you can have a north territory, south territory, east, west territories can be there. And you can also have products associated with it. So for in this particular case, what we are doing is we are creating the context, bounded context. And based on that, first you are creating concepts and sub-concepts. Okay. Based on that, you are creating logical domains out of it and the APIs to support it. Okay, and all these things are there. You should be able to look at it. These are then coming the bounded context out of it. Bounded context helps us define swim lanes. What swim lanes? That means can they be in the same database? I don't care. They need to be swim lanes. That means you cannot directly call that particular API. That's the main thing which you have to consider while building this solution. Now, this is what we do. We then create something called as a context diagram. Context diagram says that, hey, I have a user who inquires the products. I get the product list of products, give it to them. Now, I'm also having a content management solution. Fraud management is there. Hey, is this a fraud? Is this person a fraud or not? I'm able to find that information. Based on that, we create this context diagram. These are different ways of creating context diagram. Then I do ISO standards. Now, this is very important, guys, for you to understand. ISO standards we're going to create here. So let's go to the orders first. So you go to schema.org. Okay, so schema.org is the order is there. So order slash order is there. So I already have some entities created for the order. So if I look at the JSON LD, tell me, you're going to use the ISO standard for this or not ISO standards? You're going to use the ISO standards. That means if your product manager say that, hey, I need to create a discount, I need to create a discount currency, what are you going to use? ISO 2417. Yep. So that's very important for us for you to use. Based on that, you're going to build that particular model and then be able to use in your system. That said, you're going to research it out and find out the best solution for you based on this particular structure. Next, what you're going to do is you can also look at different other formats. Micro format is another format which you can use. And in this micro format, you can have organizations, events also is there, which you can put as part of this. And if you're publishing a particular product data, you can use the H product also in this case. Anybody has used the micro formats? Yeah. in the UI. If you're building the UI, you will be using the micro formats to build this particular solution. Now, this is where we are trying to find out the micro format which is going to help us build that particular solution. Hey, what's the name looks like? What the brand looks like for us? What's my H card? What's the email for that user is? Now, this will help us identify it across the board. Like this becomes like a format browsers understand also. So that is the main purpose of using this. Next is, hey, we want to build this in a standard format. Standard format means OData. So OData is a standard format which we can use. So let's go to OData now. So if I go to OData, this is the ecosystem of all the, anybody here use SAP? SAP, yeah? Oracle, SAP, Microsoft, SQL Server, any product you think about, Salesforce, yeah, anyone using that product, they all use OData behind the scene. So that means when you're building a solution, you want to build a solution in a way, and what you can do is you go to the Exodata, click on the Exodata from here. Now you're going to get a schema. Remember I showed you the schema before? This is what the schema was. This is the third normal form in the API definition. That means anybody who's using the linked data, because we know we all need to build the linked data, yes? Anybody using the linked data now can build the UI automatically. So for example, what you can do is you can go to the data explorer, see this here? You can now pick from here, I want to uh, pick the products, top 20 products, get the data to top 20 products. So I got all the data for top 20 products. What are the linked data? Who are the suppliers for these products? So I can actually find out what products the Tokyo traders create. So this is a standard format, not only for searching. See this, what I'm doing here is I'm doing a search model here. So instead of this, I can remove this, I can expand, say that, hey, I want only these columns. So partial items is very important concept because you don't want all the data to be retrieved back. That means you only send the data which is needed in the UI screen for you without writing a single code for yourself. How do we do that? Using OData also you can build that particular solution. So I suggest you should look at this more in detail, and then it will be very helpful for you to use. Now, what it does behind the scene, what it does, it uses the client and the server side both. So, for example, if I can use Java or .NET or any of my applications on the client side, on the server side, I can use any of the data sources to kind of build this solution. What that means that if this is an example of SAP, where I have an application, and here instead of SAP, I can have Salesforce here. Doesn't matter. That means my UI can automatically get generated just by doing this without running a single line of code. The UI will get generated for this. That means you're using all the best principles of REST APIs. Yeah. That means it needs to be stateless, cacheable, but then adding on top of it OData, object data model. Yes. That is the advantage. So I suggest look at the OData, look at schema.org, look at OData, and then see what's the best principle for you to use in this case. All right. Then the next one is you can also do Postman collection. In this one, it's a pretty easy way to do that. How about the industry specific design? Now you may ask, hey, I am a healthcare. How many are healthcare? How many are finance? Yeah, would love to see a standard for that. Huh? Yeah, so let's do that. So because you don't want to start building the standards by default. So this is a universal data model. Universal data model using something called UCMB model, which we call it, um, which we are trying to create here, using a universal data model. And let me go to that first. So this is the universal data model. What you can do is if you're trying to build a party, anyone who know party, like an employee, like I'm going to show you a few of them. You can look at other ones later on. So I'm going to pick here party. So this is actually coming in. A party can be a person, an organization, and a functional group. That means an employee can be a vendor also. Yes. So that's a party model which is coming up. That means if I go in more detail, contract. A party can have a contract. So if I go to a contract, so a contract, a contract has a ownership by a party, which is used by the organization. A contract has an attachment and other details. See, and a time entry associated with it. That if you are trying to build contract, where are you going to go? Universal data model. Yes, makes sense. Yeah. So that makes your life much easier. Like you're not starting from scratch. That's the main purpose behind it. Next part is common data model, which is called a CDM, common data model. So this is the common data model. Let me open up the link for this for you. So this is an assignment for the common data model. This is the Microsoft common data model. Guys, like, this is used by all the industries across the board. And I'm going to go into that data model right now. So this data model is kind of providing us all these, different domains. So if you see here, it has got HR domain, it has got account domain, sales domain, service domain, yeah, marketing domain. So that means you can build a data model using these relationships. Okay, so that's the advantage of creating this data model. Let me show you GitHub. So there is a GitHub link also for this. Let me show you the GitHub link to give you an idea of what's going on here. Now if you see in this GitHub link, how many here from banking? So if you look at the banking here, now you get all the things which are related to banking, including account, contact. So anybody who wants to create a particular attribute, look at this. Yeah, that will make your life much easier with API definition, how it is called. Yeah, that's the advantage which is there with this. Now, once we created this data model, now you can go in detail and then find out. This is a similar model. Anybody from retail industry can use this. This is called as ARTS. ARTS is a standard which is used. This also helps you understand a little bit more detail about using the system. Now what we did was just in 5-10 minutes, guys, you have got industry standards to use. So don't create any object till you see whether this object already is there. Yeah, that is the whole my premise of doing that. Next is choose the data type. See, OData is one of the collection type. Yeah, and you can also pick JSON as a collection type. Write the profile for it, implement the solution, and then sketch the solution for yourself. For example, if you're doing online payment, now what you're doing is you want to find out all the endpoints, data structures, and error handling for us. Now, in the PayPal, now this PayPal is there, like this. If you go to the PayPal example, it and PayPal actually, by the way, gives the APIs for you to try it out, because you want to see how the actual APIs are built, across all the systems. So you can actually explore these APIs and look at it in more detail how these APIs are built. So PayPal is there. You can use the Postman collection to try them out if you want to. Then you publish this API. Now your APIs are clean and be able to use the system. Now, the perspective from the microservices is one of the things which I have seen many people struggle is we create the microservice and then we stop right there. What I'm saying is don't stop right there, but do what I'm telling you next in next 10 minutes. Okay? And this will help you define the problem really well. The first thing is create empathy map. Empathy map means how the customer is feeling. What are their pain points? If you identify the operation person's empathy map, how much time do they take for any production issue to be resolved? You need to reduce the time to detect the failure and use it. So what are the questions? Who are the customers? What is the purpose? And how we build that particular solution? Now, for example, in case of Uber, this is the eco worker. I walk every day, and this is part of my happy life, and I want to move around to all the places with eco-friendly. So he does not own a car. That's what it looks like. Yeah. And then he's trying to go for a scenario. Now it's a Saturday night. He wants to go with his friends, enjoy, do the party, and then do the party afterwards also. After party. How many here have done that? Earlier we used to do that a lot. But the perspective is you find out those personas and then try to build those based on that persona. Now, what are these? By the way, this is a service which you are creating. What is this? A microservice, a new microservice you have created. So, what is your job as an architect? What are the different microservices you can create on top of the existing microservice? That's the main thing which you get. Commuter is the same thing. Hey, I commute to the city, and within the city, I need to go hop in to all the different places. And she is urban, but she goes in the weekend and work on it. Now, the important part is the fail points, guys. If you understand the fail points really well, this is going to help you define the problem for you. Now, Uber was a monolithic application. Now, they created a bounded context later on for all these microservices. They created the bounded context. Earlier, it was all in like one show, like Postgres SQL was there. That was the problem. Now, what they did was, a driver is there and a passenger is there. Passenger wants a ride. When the passenger wants a ride, what can go wrong? That's the first question. Anybody has a problem like you're trying to go from one place to another place, and then you say that I'm here, and driver is saying I can't find you. Yes, you say that you have seen this problem. Yes. So what is that? That's a production issue. Yes. Is that a production issue? Yes. So what do you need to do for that production issue? How can you fix it? How can you fix the production issue? So Google Maps don't have access points. Yeah, they don't have access points. So what Uber did, they created access points. So once they created the access point, what happened? They created the access point. Now they know where the user is. Hey, you want to be picked from here. They saved themselves. That is a microservice they created. That's the whole perspective. It's not the product owner who's going to tell you what to do. But look at your production issues and you're going to find out more issues which are there. So there are a lot of services they added, like demand and supply service they added, matching service they added. So you can add as many services as you want depending upon your use case. Hey, this is a production issue. How can I automate it so that production issue goes away? Now there is no production issue based on that. Yeah. So that's what we did. Now you find out what's your availability. 99.99% available. That means you want to make sure that your system is up most of the time. Only 5 minutes is downtime, which is a tall order. Cost of operation needs to go down. How did they do that? Okay, another microservice, text message. Okay? That's all they thought through. How they do that. And response time is less than 500 milliseconds. You need to find out these things. What are your agilities? And then be able to work on it. Now, this is Amazon did a delay of 100 milliseconds in 2007. They lost 1% of the sale just by 100 milliseconds of cost. And blink of an eye. This is 2000. This is New York Times study. Blink of an eye. That means a magic number is 250 milliseconds. If your response time is more than that, it's not good. Okay. Now that's where the Uber case study is there, like where you can actually go in, and if you get time, you should go through this case study, because in this one, I have given the architecture of how to create the case study, how to create ride and other things like that. I would not go over it right now. And then of course you can integrate with other people also very easily. Now, the perspective is integration. That's a problem. Yeah, that's a bigger problem. What's happening is that you are a customer. Customer is B2C. What is B2C? Business to customer. Yeah. But normally what happens, it's not just B2C. It's actually B to B2C. What is Amazon? Anyone? Amazon is B to B2C. That means Amazon don't have all the products. They don't have all the products, but they are actually having vendors supporting them. So they are connecting into the staging environment, and then ERP solution is their CRM solution when they are trying to build the solution. So what happens is, in this case, you need to look at it from the top. You can look at different ERP solution, SAP solution, and this is our solution. How they are integrating with each other. That's the key thing which is there. Now, art of scalability, Martin Abbott and Fisher, they talk about this. How do I scale my system? How do I scale it? That's a problem. This is where the microservices comes in. How do I scale my system? Anyone? How can we scale? What are your thoughts on scaling? Microservice you need to scale. How do you scale? Hmm? Horizontal scaling, vertical scaling. Yeah. What else? Hmm? Request driven, partition the request. Yeah. So absolutely, yeah. So what we can do is we can I can increase my server size, which is like one way of doing that. Another is by function. That's the microservice domain. Another is by splitting the customer by request, which is coming in. That means a VIP customer is there. They get VIP treatment. That means the bandwidth used, see, this is very important to understand. This is something called as a traffic shaping. You should be able to build the traffic based on that particular service when you're building it. So horizontal split by function. So duplication split by function is another thing which you can do. That means when you're trying to build a shopaholic application, you know, whenever they enter the product information, products can go to multiple different places. Yeah. So you can actually build the solution. You can split the solution across the board. Now, for example, there is a disaster which took place in one of the data center, which is containing that product. What are you going to do? Route the traffic to another data center. So that you can do by splitting the traffic. This is called splitting while in motion. While splitting while in motion, this has been used by many companies, across the board, to build their solution. Now earlier it used to be something like this. Here everything was one, and it was a microservice doing everything. We need to separate that out. That means a REST API is there. From API gateway we create different microservices to build our solution. Like we did say, hey, Twilio for the text messaging. We can text message it also. Not only that, when I'm calling from the load balancer, see, I co-locate the service. I call this as a pod. What am I calling it as a? I'm calling this as a pod. If this pod goes down, I route my traffic to another pod. Okay, so that's another thing which you can do. Now, what happens is passenger data is separate, driver data is separate, and trip data is separate. They need to interact with each other separately. That's the main thing which is there. In this situation, like Amazon, we were talking about order history, reviews, all these things we are showing in the UI. Yeah, all these things needs to come in from different data sources. They're not all coming from the same data source. So this means that these are different microservices which are coming to single page. Yeah, so you need to build using that. So the case study here is an e-commerce website is experiencing a surge in the traffic due to a popular product sale. The website's backend services are divided into multiple microservices, and one of them is responsible for retrieving the product information from a third-party API. Now, this is very typical. Something is you're trying to retrieve from the third-party API. Yeah, the microservice has a latency due to heavy traffic on third-party API. What is the bottleneck for this? So, what can we do? Hmm? What can we do to protect? This is a very typical scenario. Like you're going to call a third-party API. Third-party API is taking a long time to retrieve. Huh? Circuit breaker pattern. Yeah, you can apply a circuit breaker pattern here. What is saying? Caching the response also is something which we can do. Absolutely. So it depends upon, like how we are trying to create that particular service. So certainly we can add a circuit breaker pattern for that, which kind of like circuit is closed and open. Depending upon the circuit closed and open, you're going to have a different response from them. And of course the circuit breaker will help us like auto heal. Like don't send the traffic to that pod or microservice till the time that is up and running. So that's one way to deal with it. Now what happens is cache. That's something which you are saying, cache. So what happens is, like let's say this is a cache. First I need to go to the cache. If the cache goes down, I need to go to the supply chain database and get the information from there. Yeah, is that the way we implement this? Yeah, normally. We have expiry for cache. That could be another thing which can be there. But you know what? What to do if cache fails? You call the supply chain database, yeah. But you know that's anti-pattern. What would become a single point of failure now? Database, yes, because database has certain amount of pool information is there. So you know what this is Amazon did. That's what I'm saying. Copy, control C, control V, monkey see, monkey do. So they did exactly this, and they said that they they actually said that this is something we learned from. Nobody should do this. Yeah. So what this means is sometime it's no fallback. It's a better thing to do. Yeah. What that means, you fail fast. This is Amazon telling, not me telling, guys. Okay. But this is something proven that you want to see which is the single point of failure and then build your solution based on. This means that fail fast is the better methodology when you're building a solution. That means if recommendation service breaks, hey, fail fast. You know, you show cached values is perfectly fine, or say that hey, it's not working through. Yep. Now service down options like we talked about network timeout. You can do. You can say hey, this is going to time out after some time. Service limits is another thing which is very important. Depending upon the customer, you have different service limits for it. That means if a customer is a trial customer, you're going to give them only 1,000 requests per hour or something like that. If it's a VIP customer, you're going to get them a better treatment. So that's another thing you can do: circuit breaker pattern and fallback. Yep. Another thing you can also add is the client-side discovery and the server-side discovery model, where you are having a registry, service registrar is there, which is whenever any service registry, all these services are registering to it, and it gets the connection from it and then call that particular service. So you can do both on the client side as well as the server side. This does not mean that you only have to follow one model. Okay, some people say, oh, just follow one model. That's not true. You can do both of them at the same time depending upon the situation. Let me explain you what that means. Something good to understand when you're building this solution. You can read through the notes because I don't have time to read all the notes for us. But if you see here, what we are trying to say, client side discovery, when we are trying to do, we are trying to use any of these solutions. You can also do the same thing on the server side. Whenever any request is coming in, it's coming in from the load balancer. Yes. So first it's hitting the content delivery network. Yeah. From content delivery network, it's routing the traffic depending upon how the traffic is coming, from which customer it's coming. It routes the traffic to the correct API gateway. That can use client side discovery. Server side discovery is when you're using the microservices side. That side can use the server side discovery when you're working on this. Make sense? So you can read through. That's what I'm saying in this particular case. Now we all know about stagger fig pattern is there, where instead of try to build this monolith, create ideal design. That's what I said. Yeah, build the APIs step by step. Build the APIs first. Yeah, that's the number one thing I said. Then separate the front end and the back end. Once you separate the front end and the back end, now you are trying to add a newer microservice API out of this API, which is calling through facade layer. Yeah? That is what the pattern which we are using, which we are calling it as a facade pattern, which we already talked about before. So that is one way of really connecting and using our system. That means you are trying to add the microservices and creating the anti-corruption layer to call the legacy application. That's the premise behind this model. So what that means, you're trying to create the bounded context. We talked about the bounded context. Based on the bounded context, now what we are trying to do is we are trying to call that through an abstraction layer and building that solution. And then that big ball of mud is coming down. See, it's now pulling down to a smaller step of mud. So designing the loosely coupled microservice, that's another thing which always comes in. How do we design for loosely coupled microservices? So you want to build A is dependent upon B, B is dependent upon C. This happens all the time. Yes. What do we do in this case? Anyone? The actual pattern for this. Yeah. Anyone? Mesh is one thing, but think about differently. Like when you have all the dependent services are there, you want to keep them close. Yes. That means we put them in the same pod. Yeah, put them in the same pod. If you put them in the same pod, co-locate them. This is the pattern which is, by the way, used very heavily. It's used, and this actually gives you a much better performance. Yeah, so that is one thing. Second thing which you can do is reduce the number of requests which are being sent. Number of requests sent, that is something you can also reduce. Okay, so these are the two things when you do that will really help you build this particular pattern. So Netflix did that, by the way. 2009, they were making 9 calls across the board and using it. They reduced that to 2 calls, and then now they were able to create an aggregation pattern. So this aggregation pattern is calling asynchronously all the other APIs. Did that mean that, like, this API is taking more time? It's going to take time to return, but you can call them in parallel. So parallelly you can make a call. So that's the asynchronous pattern you can use when you're trying to build this particular solution. Another thing very important is, if you're calling from the API, from the client you're calling the server side, the timeout for this needs to be bigger. You need to know that, like, because who's calling me? That services timeout need to be a bigger timeout when you're trying to build the solution. Okay? All right. So let's take a look at it. I think we have 10 more minutes. So I think we can continue on this journey. So another thing is cancellation pattern. So cancellation pattern is saying, like, when I'm trying to book the ticket, what happens? I need to create, if I cancel my flight or my hotel, I cancel my flight here. That means I need to cancel all these things. You have to build compensation pattern as part of the APIs. Yeah. So you need to support something called as delta. Delta load. You need to support what? Delta load for everything. That means somebody can ask you, hey, give me what you did for last 4 hours, and your API should be able to retrieve that particular data when you are building the solution. That is something which you can do using command query request segregation, CQRS model, which you can build. And this kind of helps you build this model where you're trying to save the data and then you're querying the data, which is using different data models in this case. Okay? So before I do anything else, guys, I want to just talk about, so we talked a lot of things here. Okay, so let's talk about this first. So how about throttling? So throttling is a big thing which always comes in. So throttling comes in. So throttling comes in means, like, when this is a pattern which I am devising called hurricane pattern. So hurricane pattern means that, like, when you are trying to build your solution, create your services and mark them as level 1, 2, 3, 4, and 5. What is it saying? So when you're trying to make level 5, that means when the category 5 is coming, all the other services are not needed. Okay, when you build this solution like this, now you're more scalable, because even if you add more servers, it takes to add a pod. How much time does it take to add a pod? Anyone? It takes 3 to 5 minutes to add a pod. So you can't add, even if more requests are coming in, you can't really support that. By doing that, essential and non-essential services, now what you're doing is, let's see here. So Microsoft, anybody use Slack? Slack, yep. And then Teams, yeah. There is a feature there where the other person is typing. You can see the other person is typing. They are responding to me. My manager is responding. Yes, important. But is that an essential service? It's a non-essential service, yeah. So what can you do? When the load is high, you just stop that service altogether. And that way, now you get bandwidth to really work on to be able to now scale your system. Yeah. Now, so that's one thing which you can do very nicely to implement the solution. At the end, I'm going to talk about e-commerce. Okay, so this is going to be an important discovery for all of us. So you are an architect. For the last 10 minutes is the crux of everything which I'm discussing. So we're going to discuss that in detail. Okay, you are an architect. You are building a microservice API. The requirements, we already discussed a lot of the requirements. Yeah, requirements are there, like based on the support. You should have search functionality. You should have non-functional requirement, functional requirement. All these things are here. You're trying to build these APIs, and how to build this API is something which we are kind of discovering right now. So sellers should be able to add new products. Website should be able to have catalog of products, and buyer should be able to buy the product. Yeah, and availability 99.95% available. What that means, and highly consistent data. So the questions, well, I would not want to worry about the questions. Let's go to the crux of the problem. So if you see here, business to business. So what's happening is that whenever a seller is coming in, I want to be able to create my website, add the vendors to the website, call to action, hey, buy my product, and then attract the customers behind the scene. So when I'm building my microservice model here, what am I going to do for a given vendor? Anyone? I'm going to create a swim lane for them. Yes? What is that swim lane means? They will have their own customer data, customer table, products table, order table, and so that means they're customer aware. When they're trying to build B2B2C, multi-tenant system you're trying to build here in this particular case, that means product information. When you say product information, what happened in the product? Product is not just product, it's a recommendation, photos, videos, all of them are tracked to find out where you are getting the sale from. Yeah. So that's what you are doing in this case. That means product information system means digital assets you're trying to build through online channels and other channels and sell and cross sell and upsell. What that means, somebody is buying a bike. Somebody is buying a bike. What they need? They need helmet. Yes, that's a cross sell for you. So that's something which you're trying to build, and then you can do the math here later on. But basically, you're trying to create a multi-tenant environment. You're trying to create an EC2 instance where you have a customer table, product table, and order table. Yeah, using a service which is called as a store creation template. Next, when you somebody logs into the system, you're going to create a service right here for recommendation service, which is going to go in and get the products from ready-made products ready to go what I have purchased before. Yeah, and through Kafka I need to get the product. Now what happens is I have also got any user who logs into the system, I can have a Redis cache. Now I can get all their data cached, what that user has done before. That means all their browsing history and other thing I'm caching. Am I caching all the customers? Am I caching all the customers? I'm caching only active customers. Yes. So that is one optimization I can do here. And then your active customers you're doing when a new product is added. What is happening when a new product is added? It's being sent through a Kafka stream to a Spark so that my recommendation service is ready, and also to Elasticsearch. Now I have a search service which is calling from my browser. I want to search for a bike. It's been called from here, and then I'm able to retrieve that value. So this is another microservice I added. I can have a wish list and a cart and a warehouse service. So now you think about like different microservices are coming up. Location-based microservices can also come up in this particular case. Yeah? And then the perspective here is that you are trying to find out, hey, what are my old orders which were there? I can go and find out order service. You find out all the orders. Now problem comes is that how many millions and millions and millions of orders? Rohit, can I put it in MySQL database? Can we do it? No. What does Amazon do? Monkey see, monkey do. What do they do? Hmm? No, no, they still use MySQL. It's not dynamic. You only need 3 months of data. So 3 months of data, you keep it here. So any return comes in, you still transactional bound, everything good. But anything more than that, you don't need it. So you put it in an archival. You have a data archival strategy. So in that case, you put it in the DynamoDB. Everything else, you put it in the DynamoDB. Yes, they put it in the DynamoDB, but they also use the ACID property of MySQL as needed. Make sense? Same thing is true. The order is being placed. When the order is placed, order is being placed. Now logistics service find out order is not there. It happens. Diwali time, what happens? Like everybody buying same thing, yeah. So you're not going to find that order. What are you going to do? Compensation pattern. You're going to apply the compensation pattern and be able to support that. So that's where what is called as reconciliation service. So I'm trying to tell you problem and solution. Problem and solution. That's the way you have to think when you're trying to design the solution. When you're trying to build the solution, check the availability. If it is available, yeah, it's late delivery. That is called a compensation pattern I'm trying to build here. Make sense? So that is another thing which is very useful for you to do. Same thing is true with the database also. When you're trying to build historical data, this is, we talked about historical data just now. For us to build Cassandra database or DynamoDB database, you can use, you can have an archival strategy also for that same thing. Basically, you're trying to build swim lanes and you're working within that swim lane to make sure all the data is getting transacted across the board. Make sense? So that's it, guys. Thank you.